5G decides who gets data,
every millisecond.
and if a packet fails, HARK rescues it instantly before you even notice. This is how 5G stays fast, fair, and reliable.
In every 5G new radio network, the base station, or G Node B, doesn't just transmit data blindly. It continuously decides who gets resources, when they get them, and how much they get. This intelligent decision-making process is called scheduling, and it works hand in hand with HARQ, the mechanism that ensures data is delivered reliably, even under poor radio conditions. Together, they form the brain and the heartbeat of 5G's physical layer efficiency. Scheduling happens every transmission time interval, or TTI, typically 1 millisecond or less. The G Node B assigns physical resource blocks in time and frequency, balancing throughput, fairness, and quality of service. Schedulers can be channel-aware, priority-based, or latency-optimized, depending on the service, from eMBB streaming to URLLC control links. At the same time, uplink and downlink schedulers operate independently, though both report to the MAC layer. 5G supports both dynamic and semi-persistent scheduling. Dynamic scheduling adapts every TTI, ideal for bursty data. Semi-persistent scheduling reserves resources periodically, perfect for voice or control channels like PUCCH and PDCCH. Scheduler also consider MCS, modulation and coding scheme, beam direction, and CQI, channel quality indicator reports. These reports tell the G Node B how strong or weak the link is, helping it match users to the base modulation, 64 QAM, 256 QAM, or higher. Even with intelligent scheduling, the wireless channel is unpredictable. HARK adds reliability through quick retransmission. When a UE receives a transport block, it checks errors using CRC. If the block is clean, it sends ACK. If not, it sends LAC. The G Node B then retransmits, but not the same data. It sends redundancy versions, enabling soft combining at the UE. This boosts the chance of successful decoding with minimum extra overhead. In LTE, HARK was synchronized and limited in flexibility. 5G new radio introduces a synchronized HARK, allowing dynamic timing for retransmission and better coordination with flexible numerology. New radio also supports multiple HARK processes per user, typically up to 16, which keeps the data pipeline full, even while waiting for ACK and NAC feedback. This parallelism is key for sustaining gigabit throughput and low latency simultaneously. The scheduler and the HARK form a closed feedback loop. When HARK feedback arrives, the scheduler adjusts MCS or resource assignment instantly. This tight coupling ensures high throughput in good radio conditions and graceful feedback when the channel fades, a foundation of self-optimizing 5G links. So next time you stream a 4K video or download a file in just seconds, remember, deep inside the G Node B, a scheduler is making millisecond level decisions, while HARK silently ensures reliability. In episode 8, we'll explore timing advance and synchronization, how every transmission stays perfectly aligned in time. And that's all for today. If you like this video, please subscribe, share, and like. Thank you.